Okay, we are doing 2.2 here. We're graphing a line. These are all linear equations in this unit. And we're using what's called the intercept method for graphing. We're graphing lines in standard form. So there are two ways to represent lines, and we're going to start with this one where you have ax plus by equals c. I have an example here. So we have 2x plus 6y equals 12. Now this is kind of a nice example, as you'll see. The method that I want you to use is to make a little chart. So we're just going to, next to it, make a little cross thing like this and put x and y. And you're always just going to use 2 points. You're going to say when x is 0, what's y? And when y is 0, what's x? And you get two very simple equations. So when x is 0, just cover up the x and ask yourself 6 times what gives me 12? Or just divide both sides by 6 and you're going to get 2. And then when I cover up y, and I have y be 0, and I ask myself 2 times what gives me 12? Well, that's going to be 6. Okay, then I just plot these 2 points. That's the intercept. This is our x-axis. This is our y-axis. So the x-intercept is where it is on the x scale, and that's at 6, 0. So I go over here to 6, 0 and make a point, and then I go to 0, 2. Left and right nothing, up 2. Just be sure not to mix up your x's and y's. And then I just draw my best straight line. I don't have a ruler, so I'm going to just do it freehand, and it's approximately like that. It's always nice to write on your line, good habit, to write the equation 2x plus 6y equals 12. Okay? So that's an example of how to do it. Now it can be a little bit more difficult, and I'll do a couple more examples. If I have another one that is say 3x minus 5y equals 10, something like that. I'll try to do it on the same scale. And again, I make my little chart, x and y, 0 and 0. And when x is 0, this one's fairly easy. It's still kind of nice. Negative 5 times what gives me 10? Well, that will be a negative 2. Or I could divide both sides by negative 5. I'll still get the negative 2. But when I plug in 0 for y and cover that up, 3 times what gives me 10? Well, that's not so easy to do in your head, but if I divide both sides by 3, I'll get 10 divided by 3, and that gives me 3 1/3. So it's possible to do it when you don't have beautiful round numbers coming out. We can still do these intercepts. In this case, it's 0, negative 2, so down there, and then 3 1/3, 0, so it'd be approximately right there. So then I'll do this one with a dotted line just to differentiate the two lines. And there's that one. And then I would write 3x minus 5y equals 10 on that one. Okay? And this will work for any equation in standard form. Sometimes you get strange things happening. For instance, suppose you have something like x equals 5. Well, this is really not any different than saying like 1x plus 0y equals 5. So we can think of it as sort of in the same way. But in this case, when I go to graph it, if I think only about the x values, I go out to 5 and make a point because x equals 5, and y, whatever the y value is, it could be any number, I'm multiplying it by 0. Alright? So y could be 10 or y could be negative 5, and I'm going to get a string of numbers all along where x must be 5 every time, and y can be anything because we're multiplying by 0. So that's why you get a vertical line when x equals 5. So you can write along there x equals 5. And if you had something like y equals 6, you'd be 1, 2, 3, 4, 5, and 6. You'd be right there. Y equals 6. So don't get thrown off by equations that have only one variable. They're still lines when we graph them on xy axes. Okay? So the most difficult type of problem might be where you have, this is example 1, this is example 2, here's example 3, I guess, and example 4. Here's our last example. If I had 13x minus 7y equals 19, something like that, we still can make the graph work by just drawing our axes making our chart, putting in the zeros, and when I put in 0 for x, it's going to be 19 divided by -7, which is approximately equal to 2.6, something like that. And then when I have y equal to 0, it's going to be 19 over 13, which is going to be approximately equal to, say, I don't know, 1.3. You can get a calculator and try it, but we're just trying to get a rough graph. So I'm going to go to 0, up, almost 3, and I'm going to go to 1.3 and on 0, and I would get a line that would be like this. All right? Good luck.